Brooklyn, but I work for the Northeast Fisheries Science Center, specifically the Ecosystem Dynamics and Assessment branch, on ways to apply risk assessment to aquaculture opportunity areas, and hopefully to kind of establish a wider risk assessment framework that could be applied to other areas such as wind energy. So I'll just kind of talk through, first of all, just to kind of get started, what is ecological risk assessment in the context of aquaculture? So you could define it as a formal process to evaluate the probability and severity of adverse effects of different stressors on the environment. Um, and this is an outline of this sort of current approach that NOAA uses for ecosystem-based risk assessment. And as you can see, it's just sort of one example of one approach or framework for risk assessment. And there are three sort of tiers. The first would be a single pressure on a single subject. And this is more or less purely qualitative, just a determination of whether or not there's the potential for an impact. And then the second tier would be that single pressure or single stressor, if it is determined to have the potential for an impact, that would be assessed either qualitatively or quantitatively or some mix of both, for potential for impact on multiple subjects. And then the third tier is multiple stressors on multiple receptors. And this involves quantitative thresholds and quantitative modeling for ecosystem impacts. So the sort of goal of the third tier is to provide an ecosystem-wide estimate of cumulative impacts, and to estimate the severity and likelihood, or risk of different hazards on multiple ecosystem components from multiple stressors. And just to kind of back up a little bit, the history of risk assessment, I won't go through in great detail, but basically the general framework and ways that people tend to think about risk and ecological risk, in the United States at least, stem from toxicology and hazardous materials studies. And they sort of the most common framework when people think about risk assessment that you're all probably familiar with is a risk matrix, specifically quantifying severity and probability on, a chart that will give you a high, low, or medium risk. And it tends to be based on like really specific quantitative thresholds, based on toxicological studies. And in the past like 10 years or so, there's been kind of a movement, at least in ecological risk assessment and aquaculture, to incorporate less of a focus on like specific quantification of probability, and to focus less on minimizing uncertainty and less focus on that exact um, sort of number representing probability, and incorporating more qualitative information. So sort of one of the goals of the risk assessment frameworks that we've been looking into at NOAA is to find a way to um, incorporate risk assessment processes consistently in areas where there may be inconsistent data available or representing uncertainty as a part of the process of risk assessment, instead of sort of focusing on minimizing uncertainty and landing on like a specific quantitative assessment of probability. So that's kind of the direction that it's heading in general, and I'll give you some examples of that. Um, so one of the projects I've been working on as a part of this position is a literature review of risk assessment frameworks as they've been applied to aquaculture and as they could be applied to aquaculture in the United States, and sort of a synthesis of that information. And there are kind of three general risk assessment approaches that have sort of been identified. So one would be the qualitative approach, which is a subjective probability-based framework. And I'll show you some examples of what that would look like. And it's sort of a charting out or an illustration of risk factors, and the events that they would contribute to, and then the like a specific risk or hazard. So it's kind of like a mapping out of contributing events and like a visual representation of probability, with that could be tailored to incorporate either, quantitative information or qualitative information. And then the second is a risk ranking approach, which I think probably is the most familiar to most people. This would include like a risk assessment matrix where you're coming up with like a specific high, low, medium risk categories based on quantitative information or rankings that would be able to categorize risks into high, medium, or low. And then there are quantitative risk modeling tools, which also I'm sure many of you are familiar with, that can provide a system of thresholds and that could be used to establish categories of high, medium, or low risk, or could be used to sort of compare or quantify risks. Um, so um, here's an example of like a qualitative risk assessment framework that we have been looking at and thinking about tailoring specifically for public communication efforts and our environmental impact statements. Um, and basically, the sort of method here is to establish what specific impact or consequence you're looking at. That's the top node. Um, and then establish which events would contribute to that. That's like the second tier of nodes. And then the third tier, these are the risk factors that would contribute to the likelihood or increase the likelihood of these event nodes happening. So you have kind of, and you would sort of work from top down. So establish exactly what you're looking at, what the impact would be, figure out which events would contribute to that, and then figure out which factors would make those events more likely. And then from there, you kind of work from the bottom up in establishing the probability and uncertainty of each of those nodes. And the internal color of each node represents the probability. So you can assess like high, medium, or low probability. And the way that we've been sort of setting out to do this is through like a Delphi method kind of expert polling. So sort of getting like a rank of like high, medium, or low, and then using that to get the corresponding color of these nodes. And then depending on how complicated it is, you can either do this manually to combine the the internal and external estimations of probability and uncertainty, which is the outer ring color here, and then combine that for the contributing factors into each event. So you can see here that the contributing events, if there's a high level of probability of the contributing factors, then there's also a high level of probability for the for the events leading to a high level of probability for the consequence. So that is, I think there are a lot of advantages of this. I think it's a really useful public communication tool in addition to also just mapping out like specifically what are the risk factors. Um, and one of the reasons that I think we're sort of choosing to use this in risk assessment processes is that it conveys a lot of information very clearly, and it also conveys uncertainty as a part of each of these considerations, instead of as sort of like a side thought or a separate consideration. As you can see, each of these nodes has an indication of the uncertainty level. And then this is probably what I think maybe many of you are familiar with, uh, the risk matrix system. Um, so this example, this uses a site-specific index and an environmental index for the two um, for the two sides, but typically it would be severity and likelihood. And in our decision-making processes and risk assessment frameworks, we're sort of at the very beginning of considering how to use a risk matrix for like gear standards and gear comparisons, where there's already a well-established probability estimation available for like gear failure rates. And we're sort of starting to think about how to quantify severity and use that to make a risk assessment matrix. Um, but yeah, for many of the processes that we're to which we're thinking of applying risk assessment, the I think there's a push to sort of incorporate more qualitative information, and to represent uncertainty in this way. Um, and then in addition to that, there are many quantitative models that have been used, and that are being used, like for example, Omega is a genetic introgression risk model that is sometimes used for aquaculture permitting, and we're working on a decision tree of when it would make sense to use Omega for permitting considerations and when it would make sense to use a more qualitative model. So that's sort of in the early phases. And the two so that's sort of an overview of the risk assessment frameworks and processes that we've been looking into. And the two, I would say, I mean, there are many ways that people are sort of thinking about how to apply these, but the two main current applications that are underway are to the NEPA process, that's the National Environmental Policy Act, and then the other is the Endangered Species Act decision-making process. So the NEPA, the National Environmental Policy Act, is a law that requires public disclosure in the form of an environmental impact statement, of any environmental hazards or impacts whenever there's a federal action. And so this is maybe more of a public communication tool, application of risk assessment. And then the Section 7 consultations that's like a pure decision making tool. There's sort of a need to determine whether or not a federal action has any potential to jeopardize the existence of endangered species or threatened species. So it's kind of like a specific decision-making process. And currently, there isn't a lot of cohesion or uh, consistency in how the decisions are made of whether or not an action would require further consideration, or if it's determined to um, not be likely to jeopardize the continued existence of an endangered species. So we're sort of drafting a risk assessment method to sort of formalize that process. So this is the Section 7 consultation process. You can see you have a federal action, and then the first decision-making point is whether there's no potential to have an effect on an endangered species, or if it may affect an endangered species. So that's usually like a fairly straightforward decision. But the next kind of tier, after, if it's decided that an action may affect an endangered species, we're working on a risk assessment process to look at the severity and likelihood of adverse impacts, and sort of routinely screen based on consistent questions, whether or not this second decision making process of whether it's likely to have an adverse effect or not, um, sort of coming up with like a routine way of looking at that. And of course, I mean, it still requires like thought on the part of the decision maker. And there isn't always a complete information or data on the project that's being proposed, but we're sort of working through a way of thinking about that consistently and categorizing risk in a way that would point you to either um, likely or not likely to adversely affect, which would require either an informal consultation, or a formal consultation, for Section 7. And then NEPA, which is the public disclosure requirement that I was discussing, this I think that there are a lot of potentials for risk assessment to be applied to NEPA in different contexts. In the context of aquaculture opportunity areas, it's particularly valuable because the um, the aquaculture opportunity areas are very geographically large, and the ecosystems are that they will apply to are pretty varied. And being able to represent the scientific information that we have, from all of these different areas, and incorporate qualitative information and kind of expert level judgment calls to come up with a category of high, medium, and low risk is very valuable. Um, and I think also just the illustration for public communication of specific risk factors that contribute to specific events that would cause an impact are that's a very valuable tool. There are a few sort of impact categories where there's an issue with risk perception that really diverges from the research that the environmental impact statement will need to convey. So having that sort of mapped out illustration, I think is really valuable. Um, and there's also there's a lot of value in communicating uncertainty to the public, like in including in the graphic or including in a discussion of the risk assessment. What is uncertainty, and how strong is the information that we have on the different categories of impact? And I think the risk assessment processes, specifically the qualitative Bayesian belief network based risk assessment process I that I that I described, is useful in sort of conveying the levels of uncertainty that are contributing to an impact assessment, and varying risk factors. Um, so that's sort of where we are right now. That's just a couple examples of applications of risk assessment that we're looking at here. And yeah, I'm excited to take questions and kind of hear what you guys think. And if this sort of makes sense with I don't know, with the path that you guys are on and thinking about how to apply risk assessment.